we are starting our new unit, the third and final unit in your book, actually. Let's go to the top and see what we'll be learning here. Kind of a longer one. We'll definitely finish this before the end of the try. However, your test score will go on your try 2 grade, just to give you an opportunity to get the retakes done, so you're not so rushed with the retakes. Meaning that from now until the end of the try, the only objectives that you need to really focus on are your entrance exam, those of you that still have those out there, and your retakes from units 1 and 2. I'll get your unit 2 test back ASAP, but unit 3, the grade, the test will happen before the end of the try, but the grade will go on try 2. And it's all focused on graphing here. We're going to start talking about the vocab terms, domain, range, relations. CO18 is going to be a new one. You have not seen it before, function notation. You've calculated slope before. You learned about that in pre-algebra using a formula. That comes back now. Oh, if you're going to do it, do it. Don't just stand there. When you complain about not having any time for homework, you know who to thank.
Thank you.
No.
Use a mechanical pencil, people. Well, I'll have a mechanical pencil.
I'm not cool like that. I'm not rich.
Well, if you're not
They're like $2.
don't keep sharpening that pen.
Taylor,
Sharpen point.
If you're just gonna
You're
go
just wearing it down. You have to buy a new pencil sooner.
you're done. Who's going to sharpen my pencil? No.
Okay. Then we go into graphing in slope intercept form, graphing called standard form, and writing graphical equations. This is a lot about equation manipulation and graphing. So a lot of new stuff here. I'm not going to do that. That you have not seen before, and that is unit 3. So, we're only halfway there. We did not do CO16. You did have this objective last year in pre-algebra, so you've had experience with this. This should not be completely new. Here we go. What is a relation? Emmeline, please. What is a relation? What are your number plans? Yeah, go ahead.
Wasn't this on our entrance exam?
This was not on your entrance exam, no. You made a function table, maybe on your entrance exam? I don't remember, but this was not.
Slope intercept form.
Slope intercept form, that was on there. Finding slope using a formula, that may have been on there. Relation, anyone remember? Nope. A relation is a collection of ordered pairs.
Oh, I remember.
You do?
Yeah, I do.
A collection of ordered pairs. And a collection of ordered pairs can be anything from a function table to graph on the coordinate plane. And so you see down below here, I have a function table and then 2 graphs on the coordinate plane. It is any collection of ordered pairs. And within that relation, the domain, remember what the domain refers to?
Yes, but I don't remember it.
What?
The domain
Does that work like that?
are all the x values of the relation.
Oh, and then the range is all the y.
And then the range would be all the y values of the relation. The domain are all the x values of a relation. Because recall, ordered pairs, what are ordered pairs? Right? It's an x value and a y value that you can plot on the coordinate plane. You can use it to graph things. You can use it to represent things, right? But an ordered pair is x, y. X value always comes first. That's the order of the ordered pair. And so the domain refers to all the x value a relation has. The range refers to all the y values that a relation has. Okay? And we're going to practice this with a couple different types of relations, a function table, and then 2 of them that are graphed. Any questions so far? I won't give you questions now. I'm afraid of what you'll say if I open it up more. So the 3 types, or the 2 types of relations, you've got a function table. And what a function table does is kind of nice because it literally kind of groups your domain and range together, right? The domain would be all these x values, and the range is all the y values. So when you're writing the domain and the range for a function table, you just have to kind of recreate the list. The x values of this relation are -10, -5, 2, 4, and 0. Okay? Because they're literally in the x column. The domain are all the x's. The x's are -10, -5, 2, 4, and 0. Okay? The range, being all the y values, would be -3, 0, 8, 2, and -1. So in a function table, it's really just listing them out. They're all kind of listed for you. You just kind of recreate the list. Yes?
Why do you still have a skeleton?
I did not decorate my room for Halloween, so I will not be undecorating my room for Halloween.
But who decorated your room?
I don't know, students. Okay? And then, of course, how we use a function table is going across, right? This would represent a specific ordered pair if we were to put it on the ordered plane, -10, 3. This would represent a specific ordered pair if we were to graph it, 2, 8. But if you're talking about just the domain, just the range, it's specifically the x values, specifically the y values. Okay? Questions on the function table? Is it starting to ring a bell from last year?
Yeah.
So then what's the difference between the next two relations, both on the coordinate plane? But one is a line, one is a segment. How does that affect the domain and the range here? How's it different from a function table, Aiden?
So wait. Never mind.
Okay, Evan?
Lines go on forever.
They do.
Segments stop.
Right. So if you want to be that smart aleck kid, the next time that your teacher says to line up for an assembly or line up for math or line up for this, actually it's a segment. We should segment up because it does at the beginning, it does have an end, right? Okay. But for the domain and range of a line, since lines go on forever, Evan, you're absolutely right. What does that mean as far as the domain and the range? What is the domain of this line? What are all the x values that are included in this line here? There's a lot of them, right? If we look at all the x values that are included here, I mean, this ordered pair here represents the x value of 2, and we have another ordered pair here at 0, right? But everything in between here is included. Everything between here is included. Like, everything. Right? Because it's on the coordinate plane and not simply listed out here, we have to include things like 1.5 or -0.7 or 1/17. Okay? Every x value is going to be a part of the line. Even off the coordinate plane, right? Because what do lines do? Go on forever. And we know that because these arrows here. So even though it kind of stops here the way it's graphed, it technically continues on and on and on and on and on, which means that x equals 7, way out here, is represented on the line someplace. So, we've been down this road before. What mathematical symbol represents everything? Or all things? James? All reals, that double-stemmed R. Okay? Every x value in existence is going to be represented on the line somewhere, because it goes on forever. Same thing with the range?
Yeah.
Yes. Just like this line will continue to expand horizontally forever, it's also continuing vertically, right? So the y value of, 7, 8, 9, 10, 11, 12 is way up here. The y value of 12 is represented somewhere on the line. It's part of an ordered pair that's on the line. So for lines, your domain, always all reals. Your range, always all reals, because they go on forever. Which is different than the segment here, right? The domain of a segment and the range of a segment What are we looking for here? Evelyn. Start and finish. Exactly. Where does this line start on the x-axis? Evelyn. -1. Right? Now, only focusing on the x-axis here, it starts at -1. There's nothing to the left of this. The x value of -2 is not represented anywhere on the line or on the segment because it stops there. Right? So it starts on the x-axis at -1. Where does it finish? +5. Every x value between -1 and +5 is represented on the segment somewhere. And how you can write that, -1, arrow, +5. Okay? -1, arrow, +5. Everything from -1 to 5 on the x-axis is represented. I'll do the range in a different color here. What's that? Sorry? That's a segment. And you know the difference because a segment doesn't have arrows on each end. That's why when you graph an equation, you should be putting arrows to show that it goes on forever. The arrows the lines have the arrows. The segments have the dots. It ends there. It's not a line. So in the mathematical sense, it is not a line. Like if you ask a kid what is that, they would say a line, right? But there's a difference between a line and a segment, so we're not going to call it a line. We're going to call it a segment. You go.
What if, like, for the line, not the segment line, what if the line is going like straight up or straight across? Then it wouldn't be do all solutions in that direction.
It would be for one of them. If your line was perfectly horizontal, right? Which that isn't, but if it was, every x value would be represented somewhere, right? So the domain, or here, let's do a practice one. So let's say that our perfectly horizontal line went right through here, right? So the domain of that would still be all reals because every x value is included on it someplace, right? But what would the range be? -4, right? The range would be -4 because that's the only y value that this line covers. This order pair is 4, -4, 5, -4, 6, -4, 7, -4. -4 is the only y value of any ordered pair that's on it. If it was vertical, it'd be the opposite. Y would be the all real solutions, and x would be wherever it crosses on the x-axis. Okay. Back to this one. Start and finish for the range. Where does on the range, the y-axis, this segment start and finish? What's its lowest value on the y-axis? What's its highest value on the y-axis? Yeah. Yep. It goes from +1. That's the bottom of it, right? It does not go below this. And it goes all the way up to +7. So the range would be 1, arrow, 7.
Okay. 7 to 1 because that would make more sense because we started with the -1 on the top.
We typically go from least to greatest. You read a graph from left to right, yes. With domain and range, you typically go from least to greatest. Okay. If you put 7 to 1 on a test, I would not mark it wrong, right? But typically it's written 1 to 7. Questions on this? Very well. What if you don't have a coordinate plane? Okay, and this here is another way to write domain and range rather than the arrow. What this symbolizes here, if you were to write this in words, it'd say x is between -3 and 5. That's what that less than or equal to x less than or equal to symbol is. It means x is between those two values. I'm just as fine with you writing the arrow here. Okay, so either way is okay. But anyway, this first one, is that represent a function table or a graph? Where the domain is -4, -1, 6, 0, 2. The range is 3, -4, 6, 10, -1. Is that a function table it's describing, or is it something on the corner plane? Aiden. And how do you know?
Because there's no graph.
Well, there's no graph, But this one does represent something on the graph. There's no graph here either. How the way these numbers are written out, does it tell you it's a table A? There's really no table here either, right? So how the way these numbers are presented, does it tell you it's a table and not a graph? Ella?
It doesn't have the thing. It doesn't have the thing in the middle.
Doesn't have a thing in the middle, it's got commas, right? It's listing specific values, okay? So this would be a function table because of those specific values. Your x values are -4, -1, 6, 0, and 2. Your y values are specifically 3, -4, 6, 10, and -1. You know it's a table because of the commas. It lists them specifically. It doesn't give you a range, right? Whereas the next one, does that represent a line or a segment? I kind of already answered this. Segment, because it gives you a beginning and an end, right? So for this one, we're going to sketch a coordinate plane. It says make an XY table or graph with a given domain and range. So we're going to sketch a coordinate plane. And what you can do here to kind of help you, you know that the domain of this goes from -3 to +5. You know the range goes from 2 to 4. So if you take the low value of each of them and think about that as an ordered pair, -3, 2. -3 is the x because it comes from the domain. 2 is the y because it comes from the range. And then if you take the other one, the high value of each of them, and you think of that as an ordered pair, again, 5 is the x, it's from the domain. 4 is the y, it's from the range. You're going to get your segment. -3, 2 would be right about there. 5, 4 is right about here. And we now have a segment that on the y-axis goes from -3 all the way to +5. That's what we want. And we have a y range of +2 to +4. That's exactly what we want there. Okay? So to graph these segments, if you think about the low values of each of them, make that one ordered pair. Take the high values of each of them, make that your second ordered pair, and connect them. You're guaranteed to get a segment with that domain and that range. Pretty nifty, huh? Right? Right? This is the ordered pair, -3, 2. Here's 5, 4. You can see -3 to 5 on the x-axis and 2 to 4 on the y-axis. Exactly what we want. Okay? Questions on it? This was probably the hardest one, these segments. So are there questions on how I got that? Okay. All right. Second page.
There's still a question.
Oh, how do you know if the relation is best represented as a table or a graph? Emily. The symbols, right? If it's commas, if they're listed out, it's a table. If it gives you those symbols in between or arrow in between, it gives you a, I don't want to use the word range, but a range of values, you know it's going to be a graph. Okay. On the back side, we've got several graphs to write the domain and the range of.
How do you do that?
How do you do that? So for the domain here, on the x-axis, what values are represented? What's the lowest x value that this graph has? James?
0.
0, because it starts all the way on the left, right? And then as we move across the x-axis here, are there any values that are not included? No, all the way to 50. So every x from 0 to 50 is somewhere on this graph. Okay, it's not a line, it's not a segment, it's not straight, but it is a graph. It is a relation because it's a collection of ordered pairs that happens to make this kind of swervy thing. Okay, so the domain 0 to 50, or if you want to impress me, x is between 0 and 50. Okay, X is between 0 and 50. For the range now,
Wasting it.
Yeah, Mr. Schultz.
you're right. I need to be frugal.
1,000.
So for the range now, if we look at what's the lowest y value that this graph covers. It doesn't go all the way down to 0, does it? Tegan?
Wait. 1,000. Or 500. I meant.
Sure. I mean, it's about in the middle. I would accept 1,500 or 1,600 even, right? It's somewhere in there. And then as you go up the y-axis, every y value is included until what?
9,000.
Until just below 9,000. Okay? Doesn't quite get there. So a possible answer for this one might be 1,500, arrow, 8,900. Okay?
Can we do the next?
Sure. The next one. Take a look at it. What's the domain? 0 to 45. And you know that because on the x-axis, it starts all the way over here at 0 and it goes all the way across, all the way to 45 there. So 0 to 45 would be the domain. For the range, look at that y-axis. What's the lowest value? What's the highest?
1 to 14.
1 through 14, right? The lowest it gets on the y-axis is about 1. And every value is included until we get to 14. There's no y value greater than 14 on this section of the relation. So the range would be 1 to 14. Right? Now for the next one, even though it dips and goes back up for the range there, remember all you care about is what's the lowest value and what's the highest value. Right? Don't worry about what it does in between there. Your range wouldn't be like 7 to 1 to 13. Okay? What's the lowest? What's the highest? It gets all the way down to 1. That's the lowest. The highest it gets anywhere on here, about 13, 13.2, something like that. Okay? So don't worry about what happens in between. Just what's the lowest, what's the highest. Then the next three more the same. Okay? Looking at domain and range there. This one doesn't have the coordinate plane grid on it. It says 1 square equals 1 unit. So it starts here at 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And same thing up the y-axis here. So you kind of have to write your own numbers in, but I think you can handle it. You're smart. Okay. Then a couple word questions down at the bottom. It says, when looking at a relation on the coordinate plane, how can you tell the difference between a segment and a line? How do they look different when on the coordinate plane? Segment and a line. And then what is the domain and range of a line?
Wait, what? Wait, let's show us. How about the middle one? Is there supposed to be numbers on the middle one?
They're super small. Yeah, it starts at 0. This is 1, 2, 3, 4, 5, -1. It just counts by ones. Sorry about that. Okay, questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Yes.
For the program on the top, what's the range?
You tell me. What's the lowest y value that this graph has?
7.
7's not the lowest because it goes down from there, right? Goes all the way down to 1. And then it continues to have values represented all the way until when? 13. 13.2, I think we said. Yep. So that would be the range. Anything else? All right, homework for tomorrow, CO16. We'll have a homework check. Don't forget to go back in tonight and fix the bell ringer if you need to. And I will get your test back to you ASAP as possible. Okie doke.
So by next week,
Not how you say it.
so what's possible is possible.
As soon as possible is possible.
Huh?
That's what you said, ASAP possible.
ASAP as possible. Yep.
Yeah, that's as possible. As soon as possible as possible.
I'm just emphasizing the point.
Right?
Evan,
Did you try to trick us in the middle one?
Huh?
The middle one, the very bottom.
what about it?
Did you try to trick us?
Trick you? No.
Yeah, look at the sides.
There's arrows. It's like a
What?
there's arrows on the top and the bottom.
Oh yeah. No, those are actually supposed to be dots. Yeah, that is a segmented figure.
Wait, those
It
are
doesn't go
dots?
on forever.
Well, yeah.
It does not go on forever. It stops at those segmented points. It's not a segment. It's not straight, but it does not go on forever there.
Segments are straight.
Segments must be straight. Lines also. If it's like this is not a line. It's a swervy figure, curvy figure, but it's not a line. All right, folks, that's my math.